The final example we want to cover here in section 4.1 is on page 248. It's example 3. And in this case, it says graph the functions f of x equals the square root of x and g of x equals the square root of x plus 3 minus 4. So this one's the one that has the most meat, that has the most things happening to it that we're going to look at here. All right, let's focus on the g of x part of this because we've seen the f of x once before, and we'll put that on here for perspective as well. But on the g of x, we have the square root of x plus 3, and notice it's a positive square root of x plus 3. If you remember that shape, it kind of goes something like this. Remember, this is Karate Kid, sort of one of the arms going up. And then we have a plus 3 that's on the inside of the function. And remember, inside of the function tells us it's a horizontal shift opposite of what we think. So it tells us it's going to shift 3 units to the left. And then outside of the function, we have a minus 4, and that tells us it's going to shift 4 units down. And both of these things are going to happen at the same time, as in it's going to go 3 units over and then 4 units down, or if you like, 4 units down and then 3 units over in order for us to achieve the graph. So let's go ahead and do it right here. Put this graph down. I'm going to switch my pen color for just a second to blue so that we can see that the f of x is actually in blue. All right, so the f of x graph looks something like this. Again, starts right here at the origin and then would go like this. That's our f of x equals the square root of x. Now let's go back to black. As you know, that is my favorite color. Now let's focus on the g of x equation. On this one, we're going to go 3 units to the left. So we start here at the origin and we go 1, 2, 3 units to the left. And then we go 1, 2, 3, 4 units down. And where 3 left and 4 down meet, that is the new spot where this graph is going to start. Now I could just go ahead and draw that shape because it's going to be something like this, but we want to make sure it fits with number 3 here, our y-intercept. So before I do that, I want to get exactly where that y-intercept is so my graph looks exactly right. So I go back to the g of x and I said, let's let x be 0. And if x is 0, what that's going to do is that's going to give me the square root of 3, right? Because 0 plus 3 is 3, and then minus 4. Now, I don't know what the square root of 3 is, so that's when I rely on my trusty calculator here. The square root of 3 is 1.732. And then we're going to subtract 4 from that. And my calculator says that it's negative 2.268. So slightly between 2 and 3. So if this is negative 1 and negative 2 and this is negative 3, then somewhere right about there is our y-intercept. And so now that we have both of those points, we can connect those and have the same kind of shape as the one above. And then we've just gone ahead and graphed the most complicated one that this section has to offer.